Okay, let's get going. I need a gong like the D-School has. Okay, welcome to class today. Thank you all for coming. Hope everybody is enjoying the weather. Did everybody have a good time at the playground? Yes. What did you like most? Treehouse. Great. What else?
Colors.
The what?
Colors.
The colors. Yeah, I like the colors too. I like it that it was hand painted.
Well, the dedication of someone actually taking a project like that.
Yeah.
And raising all that money and doing all that.
Yeah. It took a lot of hours. I've been sort of following her. Yeah. Good. I'm glad you all enjoyed it. Let's move on. Okay, we did this. So everybody should have a handout that includes the evaluation form. If you don't, you can come down during the break in a few minutes. And if you're a student and haven't signed in, that's the time for you to sign in as well. Okay. I also have the sign up to meet with Dave form, and everybody seems to know how to use it. So what I really like to have is students who are working on an individual or a team project to either meet with me once a week or give me an email update. And it's important for me to know what's going on with your project so that I know you're actually working on it, number one, and to give you some direction and solve any problems you might have and have a little discussion. So it's important to meet with me. Now, there's a few people who have missed lectures, and including some people who have missed the first lecture. It's really important for you to make up all the lectures. They all have been really good, and we go out of our way to make a video and post it on the website. So please take advantage of that. If you don't, make up the lectures, that will affect your grades. So please do that. Okay. So again, I want to tell everybody to keep on working on their projects. You can't take a week off. You have to work diligently. And in 2 weeks, we're going to be having the midterm team presentations. So for the people who like to get started the last 2 weeks, this is your time to start. So if you're unsure of anything, if you're unsure about what should be included in the presentation, look at the handout that you got on the first day of class. It's also online. If you want to send me a draft of your presentation, that will be fine. It's really important that you practice it as well for the timing and stuff. So for the midterm presentations, because we have 8 projects, we can do 8 minutes each with 2 questions from the audience. So that's what you should prepare your presentation to be. I'm going to be sending out more information on presentation tips, and if you have any questions, please ask me. If there's any team that has a problem they'd like to present to the class about their project, I can sign you up for 5 minutes at the beginning of the class so you can engage the students and they can maybe help you come up with a solution. So let me know about that. So after the lecture today, there's an optional dinner at Max's Opera Cafe at your expense. This would be a chance for you to talk further with Peter, our guest lecturer today, and have a good time. So please let me know if you would like to go. Is there any students or anybody else who hasn't talked to me who would like to go to that? It's fine. Okay, I already have a bunch of people. Right, and I need to make a reservation. Okay, so next Tuesday, it's going to be a doubleheader. Professor Okamura and I will be talking about rehab and assistive robotics. Allison will take on the role of explaining about robots that help regain function for people with disabilities, and I'll be talking about robot projects that help a person with a disability in their normal life. And I have like 3 years worth of stuff, so I'm only going to do the recent stuff that I found this past year. So that'll be really interesting. And today we'll have Peter after the break. So we'll take a short break and get Peter's slides up. And for anybody who came in late, sign in, get a cookie, and get ready for action. Yeah, I got all the slides. Okay.
Is this supposed to say
You don't have
mute?
to do anything with that.
Okay.
If you hold
It says mute.
it's on,
Okay, don't. So I don't have to worry about bumping it or stuff.
yeah, it'll be fine. And I have gluten-free cookies.
Gluten-free, awesome.
Okay. So I first met Peter in 1979 when I came out to the West Coast. He was a student at Stanford, and he'll tell you about some of his early projects. So I've known him all these years, and seen him every year as well. And he's a regular with the class. So thank you once again for coming. We drove all the way from. You flew this time?
Right.
Okay. So Peter has an adapted two-engine plane that he flew into San Jose Airport. So just one of the many expertise that he has. So Peter is a rehab engineer who sustained a spinal cord injury in 1975 while climbing at Air Force Academy. He continued his education at Stanford, where he began applying engineering and design principles to overcome daily living hurdles faced by people with disabilities. In 1981, he founded Beneficial Designs, an engineering firm dedicated to designing, developing, and testing assistive technologies. His many accomplishments, which he's going to show in a multiplicity of slides, include developing the first chairlift-compatible skiing system with a shock absorber, working to establish wheelchair testing standards, developing seating systems for wheelchairs, and creating systems to access trails to improve the outdoor experience for people of all abilities. So Peter is the founder and director of research and development at Beneficial Designs, and spends much of his time traveling throughout the world, attending meetings and presenting his work. He's also an avid pilot and monoskier, and he's here today once again to entertain us. So please welcome Peter Axelson.
All right, thank you. So thank you. It's an honor to see faces that are familiar, and thank you for coming back again. And I spent about 10 hours changing and adding and reformatting. So if you saw my presentation in the past, hopefully you'll enjoy the changes and be helpful to get feedback too. I know you guys do give feedback. I read through some of the presentations from previous classes, and
So they fill out a form, and I'll send you their comments.
yeah, that'd be great. And let me know which sections of whether you like the design of products more, or the outdoor access design and all that kind of stuff. That'd be helpful to know. Thank you. So Dave mentioned that I had an accident I was an aeronautical engineering student at the Air Force Academy in Colorado Springs and had a traumatic rock climbing fall where I fell basically 165 feet off a ledge and fell through a 85-foot tree that broke my fall. And going through that tree slowed me down enough that I survived the fall. I was really, really strong when it happened. I played ice hockey in college at the academy, and so I literally got redirected into a new career in engineering, came to Stanford. I was the first undergraduate student in a wheelchair here, so there were a lot of architectural challenges and classes that were upstairs, and I had keys to all the buildings to go in through freight elevators and stuff. So it was a really incredible experience that I had at Stanford, and got to come back for my reunion this fall, which was really, really awesome, and attend a couple classes myself then. And so again, we flew down this morning. Irene is an intern working with our company. She's here in the front, and I got a 15-minute delay because a wire tie holding the heating plug on the aircraft broke. And I was like, this little plug flapping around at 200 miles an hour could cause a problem. So fortunately I found a couple wire ties and we put it back together. So it was just about a 15-minute delay. My whole day's been about 15 minutes late. So it's great to be back on track here time-wise to be able to share with you guys. So I've given you two handouts just to tell you the difference between them. One says examples, beneficial design examples, and that's going to be kind of an outline of the material, the content of the designs and things I'm going to show you. And the one that says philosophy of design, that's just going to be kind of woven in the background of what I'm talking about. So if you're wanting to make little notes about something that you see, if you follow along in the examples, you'll see the names of the things that I'm covering as I go through the images. So, and let's get started. Our company does things in research, design, and education, and this is the mission statement. And I think it's really important when you set out on your life's work. I just encourage you to think real clearly about the kinds of things you want to work on and the kinds of things you want to do. And we did this real early at Beneficial Designs, and I did it with the team of people that I was working with at the time, and helped to sort of write down, and I think Arna was part of it at that time, to write down, what it is you're wanting to focus on in research, design, and education. And real important that we thought that all people, regardless of their functional ability, had the right to participate in all aspects of life, whether it's daily living activities or recreation or leisure activities. And so that was a part of our mission statement, and we've really, it's really helped to be focused, because I don't know what the next thing is that we're going to work on. We look at okay, who's in our team of people, what's the most urgent problem we see to work on, and then we try to get funding for it and work on that area that we see needs to be done for where we are in time and history and accessibility with what's happening in the country, what laws are passing, and everything about access issues in our country changes as the legislation in the Americans with Disabilities Act was passed, and guidelines and laws for different kinds of access happen, and we've shaped our work or try to sync with that. One of the things is that when you try to do things, I can't do things without the team of people that I work with, and that team of people is all, you have to be able to work well with other people. That's really important to think about. Shauna still works in Santa Cruz Mountains, where our company was based. She's a researcher. She has a disability herself, spinal cord-like disability. Nathan is kind of a design standards expert on design, architectural accessibility. He's been working on our outdoor accessibility. We have a software and electronics designer person that works full-time writing software code to drive a lot of the assessment tools that we create. We have a wheelchair test lab, so Stephen runs the wheelchair test lab. We We have machinists, because you got to be making parts and things to make things work all the time. We have a graphic artist who was, on site with us for a few years. Now he's working for us remotely in the United Emirates. So we've got people that continue to work. Jamie's working while she's in law school for us. And then, of course, the staff people that are in the office just to keep things going. Everything you need to have to keep a company working. You have to have a bookkeeper or somebody to help you with all the numbers and stuff. And when I started, I just have to admit that I did all these things myself. I was just me. And so, I took night classes taking accounting classes, welding classes, all the things that I didn't have time to do when I was at Stanford. I just kept going with classes for another 5 or 6 years. The most important helper I have is my daughter. And since I came to the reunion, she's either wearing her Fear the Tree red sweatshirt or this one today. This was just a couple days ago. She had this one on, and she comes and helps out in the office as well. She's pretty excited about coming to visit here, aspiring student. The other thing you have to have is facilities and equipment to do the work. So we've got a shop, and I've been collecting these tools over the last 30 years. Bead blasters, powder coating ovens, trying to find stuff used and surplus. Lathe, milling machine, got ourselves a little CNC. All the stuff you need to be able to make things. And then we have a specialty equipment that we've designed. Like this is a framework that we push and pull on various parts of the wheelchair. We're pushing down on the armrest to try to break that thing to see if it's going to survive. We got weighted pendulums that we smack into casters and footrests. We've got machines that we've designed and built to run manual wheelchairs with slats that come around. You can see this chair sort of moving around in space. We have other drum machines that the wheelchair actually drives itself because it's a powered chair. And you can see there's these slats that come around and they hit the wheels, so it simulates 5 years of usage with these slats coming around, whap, 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 beating the chair to death. And this is another machine that we have to pick the wheelchair up and drop it 7,000 times to try to pulverize it. We build these test dummies out of wood, and then we calibrate them, tipping them forward and back to find out exactly where the center of mass is to match the standard. And we put the test dummy in the chair. We've built standing test dummies. This is a track chair for vets and stuff that want to go hunting and stuff out in the outdoors. And then we set the chair up and we measure the static stability. So this is a chair with a tilt and space seating system. So we tilt it back and then we raise it up until the wheels start to lift off the ground to find where the stability limits are. And then we take the chair out in the aircraft hangar. We've got a huge ramp there that we drive the chair down full speed, and we throw the brakes on various ways, simulate power outages, reversing the controls to simulate various types of failures and stability issues in the chair. Here we're actually doing a stopping test, and there's a fifth wheel on the chair and electronic timing to measure how far it takes us. And then we get crashes, things fall over, it gets exciting, weights go flying all over the place, 300 pounds of weights. And this one didn't pass the climbing the 3-inch step or whatever we were testing on that one. So it's kind of like then we go back to the drawing board and we'll shift the seating around to get these powered wheelchair products to pass. We're doing this testing for Medicare recipients. They're going to be in these patients, so we've got to make sure that these chairs are going to be safe when they go to use them. So you've got to have people and you've got to have facilities, and so then you've got to decide, okay, what are you going to focus on? So in our company, we've focused on, and early in my career, I focused a lot on products, one at a time, one design at a time. And my student project here, you're going to see in a minute, was working on a product itself. But for those of you that maybe work in industry, you'll be working on some kind of product possibly, and you want to try to incorporate universal design principles into that product the best you can in whatever way possible, because not everybody's 5'7" and standard weight and can walk and climb stairs and ladders and all that. You want to think about the full spectrum of people with vision impairments, hearing impairments, sensory impairments, and mobility impairments. So we focused on we don't focus on mainstream products so much. We focus more on how do we put universal design into products to expand their markets, and then adaptive, what I'm calling adaptive products or adaptive technology. And either, I'm going to talk about like personal technologies and activity-specific technologies. Personal technologies would be like the glasses that some of you are wearing. You need those glasses to be able to see. It's the clothing we wear is part of it. My wheelchair is part of my personal technology to get around because I have no functional ability to ambulate at all. So personal technologies are things that are essentially like a part of you that you use when you do things. Activity specific is, you know, like you have a bike because you can't run 30 miles an hour, or you have a car because you can't run 60 miles an hour, and you have airplanes because we don't know how to fly. So technologies that allow you to do certain things are what I call activity specific technologies. And so before I start talking about some of those technologies, I want to just talk about the issue of disability for a second. So I had this injury, and I'm 19 years old, very athletic, rock climber, outdoor person. Boom, I have a spinal cord injury, I'm in a wheelchair. So suddenly life has changed a lot. And it's really important for you when you're working with somebody with a disability, or if your project is working with a group of people with a certain kind of disability, to think about how that person's or that group of people's lives has changed. And to know whether, are you trying to replace some sort of physical function for that person, or are you trying to enable them to do some sort of mental task at a computer workstation or office environment, or are you working on some spiritual thing that, you know, some dance orthosis, or, you know, something that allows somebody to function in a certain domain or realm. So think about, you know, how that person's life has changed, or maybe they've been born with a disability, and how their life is very different than it might be otherwise. And so first we're going to take the time out here to talk about that. I have a daughter, right? So I'm continuing to try to figure out, well, how do I continue to do things with my daughter? She likes to do physical. She likes to go rafting. So Dad's got to figure out how to get in the raft. He's got to figure out how to go down the zip line to get to the water, or the piggyback ride to get down there. And I'm kind of tucked down in the bottom of the ramp. She's front and center in the middle. But I want to be able to be there with my daughter. So I've got this life jacket thing that we tied around my knees, sort of to make a sort of a cushion that I can squat down into the floor of the raft. So it's kind of a seat cushion, and I'm wearing a life jacket as well. So if I fall in, my legs are going to be up. My legs aren't going to get entrapped in a rock. So I'm thinking about the safety issues and all this stuff. How do I participate in this activity? Or maybe I'm trying to figure out, you know, how to go fly fishing, or to be out. Sort of, this is up where I live. If anybody wants to come visit me in Nevada, this is the Sierras. And unfortunately, there's not much snow up there, so it almost looks that green. Or your daughter decides she wants to go on a zip line. It's like, okay, how are we going to do that? So, okay, they wear a harness around the waist, but it's like, wait, when we go flying into the tree, my legs are going to hit and kind of break both my legs. So we figure out, okay, let's put a second harness on my legs and another one to hang on. I should have put one on my chest. I felt like I'd done 200 chin-ups by the time we were done. So it's figuring out how to do things sometimes on the fly and stuff. Another dimension to think about is some people are used to doing things really independently, and other people are used to doing things really dependently with other people. And then some people like to do sort of a mix of things with an interdependent way. And so, you know, this guy has to be willing to accept that he's in my hiking chair here, that he's going to need help because he can't get between these two boulders. So you got to say, okay, is this person willing? Some people aren't willing to have any kind of help, so they want a walking machine or whatever to do what they're doing. This guy wants to go skydiving so bad. He's a ventilator-dependent quadriplegic. He's got an oxygen bottle pumping oxygen into him, and there's a jumper. He's tandem jumping under the jumper. I mean, this guy really wanted to go jumping, right? It took a lot to figure out how he was just going to breathe during the 5 minutes that he's outside of the airplane until he got back on the ground with his wheelchair with the ventilator on it. Or this is me flying in one of the early ultralight aircraft and wanting to be out there. Well, ultralights, you don't need a pilot's medical certificate, or you don't even need a driver's license. So we were able to put quadriplegics with very little hand functions into the ultralight, and they could fly even if all they could, we were velcroing their hands onto the controls and things to be able to fly this ultralight, and there's no restrictions on the ultralights for legal point of view. So we talked about personal technologies. I'm going to show you some activity-specific technologies now, and I'm also going to show you some environmental technologies, things that don't move, built into the environment. So here we go. First one, this was my student project, was a sit ski, and the need basically was like, I want to try to figure out if there's a way to go out there and keep skiing with my family. And so I designed a sled-like device, and Dan Bray, my professor and advisor, who left early, was actually a ski patrolman up at Lake Tahoe, and he helped me test this first thing. As I went careening down the hill, he came and rescued me from hitting my first boulder. So, I mean, sometimes when things don't work, there's consequences, so you just got to be ready for that. But as soon as I had one of these built, lots of people wanted to do it, and so I ended up starting Beneficial Designs initially to manufacture and make these sit skis. And Wells Fargo always likes to hear my success story. I won a student design competition at RESNA, which has a competition every year, got a $500 prize. I opened a bank account and started Beneficial Designs. And that's how I got here today. So that eventually evolved into a monoski where I sit balanced on a ski with a shock absorber underneath and a mechanism to get on the chairlift. And I ended up getting to race on the U.S. Disabled Ski Team for 8 years. That was pretty awesome to be able to do that. And so now that's actually a Paralympic sport. There's 4 classes of monoskiers and international competitions and different levels of injury that do it. So it's pretty amazing what, when you don't, I just thought I was trying to, everybody thought I was crazy when I made the first sit ski. Even the professors here at Stanford is like, they literally, one of them walked up to me and said, who's going to want to do that? Well, I don't know, but I'm going to do it. So as soon as I left, took the first one to Colorado, the program director's like, can you leave this here? And he brought like 20 people up to try it. He had everybody write a letter, and he sent me this big envelope full of letters. This was the best day of my life. I'm back on the snow again. Could you make it a little longer? Could you make it a little more this? Could you make it a little more that? And so next thing I knew, I was trying to design it for 20 people instead of just myself. And so that's when I realized I wasn't the only one that wanted to go out and do outdoor recreation activities. So now there's things also called bi-skis. That's the one on the right there, and I think I have a pointer good. It's got 2 skis underneath. And all of this equipment has to be compatible with the chairlift. So we started a standards committee for making the equipment accessible with the chairlift. It's got to be able to get on the lift and off the lift. And then I don't have any back muscles. So I came up with this spring rod here. This is like a fishing pole here. It's plugged into my seat, and it goes through a plastic tube on my back. So when I flex forward using the stomach muscles that I have, then it helps me spring back up, because otherwise I just fall over if I don't use my arms to push myself back up. So this, I also like cross-country skiing. So this is a cross-country ski, and if you can see, the seat tilts forward in this picture, and then it tilts back. Well, there's bungee cords in there, so that when I lean forward, it stretches the bungee cords, and then when I pull through, it snaps back. So it's kind of like a kick and glide for cross-country skiing, and it gives me an increased range of motion pulling. And I got to go up to Yellowstone to Old Faithful this winter. I've always wanted to do that, and stay at Old Faithful and ski around the geysers up there. So this idea was like, if there's a slope on the hill, a cross slope, the 2 skis, it just falls over. So the idea here was I made these little skis adjustable, so I can actually raise that ski up on the side here, so I can accommodate a cross slope. So I call this like my backcountry ski. So I can go out into the backcountry. This is a product they call it the PaxBack, or Nick's name is Pax, Pete Axelson. But it's a simple pad that supports my lower back, upper sacrum, my pelvis. And this guy here you can see with that loosened And tightened, you sit a lot taller. I sit an 1.5 inches taller with my pack spec tightened. And when I'm going down a ramp, I'll loosen it so I can lean back farther for stability. But when I want to sit up straight, I'll tighten, just reach back and tighten that up. So that's a really neat product. I wanted to keep playing the piano. I had played the piano. So we call this Peters Pneumatic Piano Pedal Pusher. It's just a simple bellows, like a beach ball pump, inside of a plunger, pushes the plunger up to push the sustain, and then there's a cummerbund with like a blood pressure cuff. They take your blood pressure with, you just pump it up, and then by tightening my stomach muscles, I can push the pedal on the piano. So we didn't try to manufacture this, we just put this on like a do-it-yourself site, because anyone can go down to the hardware store and buy all these parts and basically put it together. So this wasn't something we tried to manufacture, we just put it out there in a do-it-yourself kind of thing. I wanted to be able to drive a stick shift again, you know, the old 4 on the floor, clutch, brake, gas. So I designed a hand control that had the twist for the throttle, push for the brake, and then rotate down into my leg for the clutch. So usually it takes like a foot and 2 hands, and you know, 1 hand on the steering wheel, 2 feet, the parking brake. And so with just 1 hand, I put the throttle on, slipped the clutch off, and let off the brake with 1 hand, and the other hand's on the wheel. So I drove this car, this little truck, for about 15 years, and it worked really well. So this is like a high liability kind of product. You kind of want to be careful selling something like this. So we have the plans to these. People sign a waiver, we give them the plans. I know of about a half dozen people that have had a machinist make the parts, and they're off driving stick shifts. Active seating. This is a balance chair. Some of you probably seen them, or some of you probably sit on balls and stuff. Just sitting in that forward posture with your pelvis forward, it really feels really good on your back. I like sitting that way. So I designed a wheelchair that sits that way too. So I could sit with my legs tucked under. And the wheelchair had 3 different postures. I could sit back onto the rear wheel, or I could sit forward on the front wheel. This is my hiking shoes. So you want to go hiking, you throw your hiking shoes in your backpack or your luggage or whatever. If I want to go hiking, I've got a whole nother piece of equipment to drag along with me. Fortunately, the airlines are usually pretty accommodating. Rental cars are a little harder to deal with because it takes up the whole back of a minivan, basically. But this has 4-wheel disc brakes up here in the front. I can crank that, and it clamps onto these discs here. And I'm on the top of Mount Washburn in Yellowstone National Park, up an old road that goes up there. We did a trail assessment up there. So we designed the seating that's in this chair. It's adjustable, so when I'm going uphill, I can move the seat up and forward, and then when I'm going downhill, I drop the seat down and back. All right, hand bike. This is one of the first student projects that I supervised at Stanford. Doug Schwant, some of you may know him, was the student working on this project. His brother actually manufactured these bikes, and you just pedal it with your arms, and once you get going, you pull up these little side wheels and you lean and steer just like you're on a regular bike. And he designed a tandem version. His brother designed a tandem version of that bike where the rider could sit in front and pedal, and another rider rode in the back. Seating. Most adaptive equipment requires some special kind of seating if you have a spinal cord injury like myself, and you have to be careful of pressure sores. So this is a sort of a topographic illustration of my seat cushion that I'm actually sitting on right now, and this is actually what's in my aircraft that I sit on. Seating pressures are a really huge issue, trying to distribute those pressures evenly to make sure somebody doesn't get a sore. So we got the idea of creating we got a plastic skeleton we ordered up, and we molded it into a gel butt, we call it. And then we could push that cushion into the wheelchair cushions to do the testing. And so that's what it looks like when you put a pressure map in between the cushion and the gel butt. And you can see where the pressures are higher. There are those yellow pressures up there. That's where the sitting pressures are higher underneath the ischial tuberosities, the sitting bones. And then you can compare cushions. So you can see, like, wow, this cushion has the lowest pressures, but that's an air cushion, so it's not as stable. It can get a hole in it. It can go flat. It's got some issues. with traveling maybe, but every cushion has its advantages and disadvantages. Some are gel, some are heavier, so everybody chooses a cushion based on different priorities. So then we made a skeleton that was an adjustable skeleton. And the reason we did that is when we make these pressure measurements, we wanted to be able to simulate a pelvic obliquity. That's where the pelvis is tilted. I sit with my pelvis tilted like this. So you want to look at, well, what cushion will accommodate a pelvic obliquity well? Or maybe what cushion will accommodate a pelvic tilt to the rear where the pressures are in the back like that. So we made that adjustable skelly indenter, we call it, for doing that. A lot of people also have spasticity where they spasm and tries to throw them out of the wheelchair. And so there's these real tremendous thrusting forces that can occur when your body tries to go into an extensor spasm. So we've looked at different angles of lap belts. We figured out that a more vertically oriented lap belt prevents people from sliding underneath. And if you look in your car, you'll see most of your lap belts in your car actually come up more than they come forward. And it's the same with aircraft too as well. So we came up with this concept, this idea of creating something that would go around the pelvis and allow a pivoting to occur. So we've made a prototype with an infinitely, like just a pivot joint down there with adjustable bungee cords front and rear to try to see how this might work. And this is the product that we came up with, and it lets people do some amazing things. It lets people that could otherwise not be very functional in their chair participate in a dance group or play tennis or participate in sports or even just be functional to be able to eat and do their activities of daily living. And we test everything that we do. So we had to make a test machine that would cycle this back and forth with the motor, and we're testing the elastic cords there and the fiberglass that's in that pivot there, and we'll test the functional reach. So we're measuring how far this little guy can reach forward with and without the hip grip. That way we can document medically we can increase the reach range by 80% with this technology, and research agencies that fund your research always want to see that you prove these things. So we're documenting the person's ability to laterally reach down to the floor. So these are some of the ways that we quantify what we're doing, and then it becomes a product, and in this case we licensed it to a company that makes seating products, which is more logical than us trying to manufacture it, distribute it by ourselves. This was an idea of, like, everybody uses different shoes for different things. You wouldn't go running in your dress shoes, right? You'd put some tennis shoes on. Well, wheelchairs, the hand rims are all just bolted onto the wheel, and you push on that thing and it's hard as a rock, and you just push on it. So I wanted to try to have an elastic connection between the hand rim and the wheel of the wheelchair. So we did that by molding rubber between them. So this is the shape of the rubber between the hand rim and the wheel rim. And that's what it looks like where the thumb actually pushes there on the rubber right there. So right away we figured out that we have an improvement in the friction. So we figured out a way to measure that, to actually figure out for a given amount of pressure pushing down on the hand rim, what's the torque that can be applied to the hand rim before it slides underneath the thumb. And we showed that we doubled the amount of friction by having that rubber interface between the hand there. We also looked at the impact absorption, and so we wanted to see, well, how would that hold up over time? So we applied a repetitive load to that hand rim with a test machine, and found out that it would break after a certain number of cycles. So we, 440,000 cycles, we thought, well, that was pretty good. It didn't fail until then. So then we wanted to study how does it affect and benefit that person from a functional point of view. So we created a wheel with beams and a 6 degree of freedom sensor there. And so we put that onto the wheelchair, and we can measure the forces being applied to the hand rim in all three axes, X, Y, and Z. So we have that smart wheel, or that strain gauge wheel, on the chair there. And then we put markers all over the person. So we put these fluorescent markers so that we can essentially create a gait lab for a wheelchair. So we can video this into the computer and see the stick figure pushing the chair. And then we wear an oxygen expired gas collection system, and we can measure the amount of oxygen that person's consuming, how efficiently they're pushing. We can adjust the angle of the ramp. We have EMG signals on their hands, so we can measure all these things. We're measuring the expired gases, we're measuring the heart rate, we're measuring the grip of that person on the hand rim, we're doing motion capture, and we're measuring the forces on the hand rim. So we wrote a dozen papers based on that to back up the science on this picture, and Mark actually got his PhD at Stanford here working on this project under our supervision at Beneficial Design. So the finished product is a hand rim. When you squeeze it, it just moves. So you can actually squeeze through narrow doors, and so it's got some other benefits too. So we licensed that to Spinergy. They make high-end bike wheels. So they make the wheels that I have on my chair. We had another product that I thought was just as cool. It actually was a rubber rim that slid, the hand rim inside of it slid around inside this rubber thing. So you could hold the rubber thing still going downhill, because we put some little plastic ribs in there that it would slide on, but when you squeeze the rubber against the hand rim, it would break. So it allowed you to just, when you pushed on it with just gross hand movement, it would contact the hand rim inside and push, or when you were going down a hill, you could just push on it to do braking. But we couldn't get funding for this one, so we had to sort of move on. We weren't successful. I like to go paddling out on the water, so water sports is a real equalizer for people. You leave the wheelchair behind, you get in a boat, if you can paddle it, nobody knows you're in a wheelchair. So we wanted to figure out how to make the seat work. Well, I had already had a custom seat molded to me in my kayak, but that wasn't going to help lots of people do this in a canoe. So this is the seating system that we developed. It's actually manufactured by a company in Minnesota now, Chosen Valley Canoe Accessories. It's got hip pads to position the pelvis and support the pelvis upright. And then if somebody needs the upper trunk support, you can add these upper lateral supports and stuff as well. So when we did the research to show the benefits of this, we took a Concept 2 rowing ergometer and bought a little kit to convert it into a paddling ergometer. So we had the user paddling it, we had our prototype inside him, wearing the expired gas measurement equipment, the metabolic measurement equipment, and we brought 30 subjects through, and we had them all paddling at different rates, and had software to show a cadence for paddling rate. And we wrote papers on that, and we measured their lateral balance. So the boat's being tipped here, and Mike's seeing how far can we tip him before he loses his balance. So we're measuring the increase in lateral stability with our seat. And we did a wet exit to make sure, even with this system, they could still get out of the canoe safely. So all of this stuff went into documenting and this, and now this is a successful product with all of this work backing up the design. Another student project that I sponsored at the University of Virginia, this guy put together a wave ski. Lots of people have been injured surfing and they want to keep surfing. So this is basically a molded seat in the deck of the surfboard, strapped in with a quick release strap. You just pull one strap and it undoes all the straps to be able to surf, to do wave surfing. Okay, so now we're going to talk about things that don't move. Technology, technology that's in the environment. I'm going to check where I'm supposed to be in my presentation. So one of the things is watercraft landing sites. There's like 80 watercraft landing sites up in the San Francisco Bay Area. So our company was called in to try to say, how can we characterize the accessibility of these watercraft landing sites? So we're measuring things, like the grade of the ramps and the high tide and the low tide and the slope and how the water changes and all that. So we came up with basically a trail, a water trail access information chart. And the things that are key here is how steep that grade gets, 14% when there's low tide. Or which way does the current go? The current is going east-west. In this particular case, what's the fetch? That's the direction that the waves and the wind are coming in from, that you're going to have to battle that current. You probably want to paddle into the fetch, right, and then come back with the wind rather than go downwind and then come back into the wind. So we tried to come up with some standardized information for accessibility to show the width of the access routes and the steepness and all that for those watercraft access routes. For trails, we developed a universal trail assessment process to Basically, it uses a set of simple tools, smart level, a roller wheel, compass, and clinometer to systematically measure the grade, the cross slope, the width, the obstructions on the trail to figure out how we can characterize the accessibility of a trail. So we send out a team of people, and usually it's done 2 people. Here we're doing a training, and they go out and make all these measurements. Well, we've trained over 1,200 people how to do this process now. So there are trail coordinators and trail accessibility experts. There are people, their job is to design and maintain trails. So we've got over 150 trainers that can go out and train people how to do this now. But it's kind of tedious, labor intensive, 2 people at a time. So we developed a system to do it. This is a sensor box that measures the grade and cross slope. We've got a wheel sensor on the wheel, got a laptop on the computer. So Nathan's over in Hawaii training this team of trail managers in Hawaii how to measure their trails in Hawaii for accessibility. And so they're using the equipment there. They also have a wheel version of it. Some of the trails are really narrow, so they need to be able to roll that equipment on a single roll wheel, and then they set it down to get the grade and cross slope. This gal's wearing the laptop to make the measurements. We also have a version that goes right onto a wheelchair. Mike Passo's a master trainer for the trail assessment process, so he's got all the equipment, got the GPS on the back of his chair, he's got the sensor box in the front here, his laptop's on his lap. So he's a rolling data collection system in his chair measuring the environment. This is what the software looks like. It's super high contrast, the fluorescent highlighter colors with the black text, so you can see it out in the sun, and that's how they collect the data. Now we're working on developed outdoor recreation elements, which is basically all the picnic tables, the campfire rings, the water pumps, the temp pads, all those things that are out there. So grills are supposed to be at a certain height. You're supposed to be able to operate them with one hand. You're supposed to be able to operate a water pump with a closed fist. You're not supposed to have fine finger control. So Mike's demonstrating you can work that with a closed fist. And then he's measuring, is it less than 5 pounds to operate the water pump? Checking all that. I'm checking the height of the handle to turn the pump on this unit. Picnic tables. One of the key issues is the access end is over on this end where you can roll underneath. You can't roll underneath this end. But you've got to be able to get all the way around the table for it to be an accessible picnic table. So we're setting up this software on a tablet device that's going to be able to run on a cell phone. So we want to be able to, we create what we call these visual guides on where you're supposed to be making the measurement to put the measurement in. This is our profile gauge. You pass it underneath to make sure there's room for a wheelchair user. Once we get all that data about trails and everything, we put it into a trail access information format. It's kind of like a food facts label for a trail. And we put it in this nice format with the grade and cross up. We put the typical and the maximum values. Now this is required by the ADA, by the Architectural Barriers Act, that trail access information is going to be required to be created for every trail in the country. Right now it's just federal lands, but so this is what we've been putting out there, these little signposts at the trail so you can see what all the conditions are, the length, the grade, the maximum grades, the percentage of the trail in different grades. At a park, we'll put all the information about all the different trails. By color coding the trails, you can look up the information on the park map. So that's on a 2 by 3 foot panel sign. This is Washoe State Park up at Lake Tahoe. This is Tahoe Meadows Interpretive Trail. So we've done all the state parks in the state of Nevada with this process. By using federal gas tax money, we've gotten grants to go out and do the measurements, and we're trying to make this happen in the rest of the states around the country. So we have a website where you can go online to say, okay, I'm looking for a trail that's at least this wide or at least this grade, and you can search for the trail, find the trails you're interested, and then go out hiking. So one of the things that's really important for access is not just to measure what's there, but actually create standards about what's there. Well, last year, or a year ago, the Architectural Barriers Act passed the Outdoor Recreation Accessibility Guidelines. And so that means now outdoor recreation access areas, there are standards now that they have to meet. There's also standards that are being written for sidewalks, the public rights of way. So we decided we'll be using all the data we had. We helped them come up with all the grades, that you can have a 10% grade for 30 feet and 8% for 200 feet. You don't need to memorize these numbers, but the point is that the equipment allowed the creation of these accessibility standards, and now when Park builds new trails or reconstructs trails, they follow these guidelines because this is good universal design. Trails that meet these guidelines don't wash out. They don't let people slide off and get killed like happened on this trail in Hawaii. And so we've come up with guidelines for cross-slope and for grade and for surface and width of the trail. Surface is a really difficult issue. Like a playground, for example. We want the playground to be firm and stable. How firm and stable? We want it to be soft enough that if a child falls off the top of the playground, they don't end up with a head injury, but we also want it firm enough that I can be able to roll on it. So we created a test procedure using that instrument and wheel I showed you with the strain gauges on the wheel. We measure the force to push the wheelchair 2 meters through that surface, 4 pushes. We take the area under the curve, we calculate the work, we know how much work it is, we compare that to a standard ramp. We want the surface to take less work than going up a standard ramp. So we created an ASTM standard based on that. Then we wanted a way to measure this portable out in the fields. Not just a lab, this previous one is a lab test procedure that we do at our company. So we invented this device called a rotational penetrometer. You stand on it and release a precision spring into the surface, and then you can read the caliper here to 100,000th of an inch, and we measure the penetration of the indenter into the surface. That gives us the firmness. So then you twist that just like somebody's foot would twist or the wheels would twist, and we get the stability of the surface. So we get a firmness reading and a stability reading. So here's a typical trail. This was up at Lake Tahoe. It was an interpretive loop. It was supposed to be an accessible trail, but it's got this sandy material in this area. They can't pave it. They can't change the material because it's in the Tahoe Basin. You can't do anything that affects the water quality in the lake. So we raked out the material. We put in this geotextile material. We raked it back into the surface and compacted it. You can't even tell that it's there. But so here's the data with our device. Firmness, the average was 0.18 and 0.17. So it didn't get that much more firm, but look at the stability, 0.82 to 0.38. So it's twice as stable. It's only half the penetration on the stability. So we really improved the stability of that surface. So when you turn and twist and maneuver on that trail now in a wheelchair, you don't just sink into it and get stuck. So that's how we objectively measure. And now that portable measurement tool is allowing trails and playgrounds and all kinds of things to be measured. So we sell that device. We manufacture those devices and sell them. So curb ramps, making cities accessible. Whole new challenging environment. The curb ramp has to be measured. The grade has to be measured. The gutter. It's pretty back-breaking work. You send somebody out there with a smart level and you got to kneel down and measure the flares and the landing and the gutter, and you're squatting down about a dozen times at every curb ramp. And then tripping hazards. Tripping hazards are the greatest liability in any city because somebody that's older and doesn't see that little half-inch obstruction and they trip on that and they break their hip, and now the city's got a lot of liability. The only way we had to measure that was with a profile gauge, trace it on a paper. So we said we got to make a sidewalk assessment process that's efficient. So we created basically a three-wheeled cart. This is an article that was in Wired magazine last year. It's got a wheel. It's got the sensor box for grade and cross-slope, the wheel sensor, GPS. We've also got a wireless wheel that we can use to measure distances. We've got a height measurement device that pushes a plunger up and pulls a string encoder to get the height down to a millimeter. So we can measure all these things. We created some software we call Public Rights-of-Way Assessment Process. And it's pretty simple. It guides the user where to put the cart on the curb ramp. So he puts it on the curb ramp, he hits the enter key, it grabs the grade and cross-slope, says now do the landing, now do the gutter, now do the width with the roller wheel, now do the length of the ramp. And what happens is you can put all that data then into a GIS map, and then we can filter it, do some smart searches. And so this green area is everywhere that the sidewalk is wide enough. The red areas are where there isn't enough width on the sidewalk. We can do the same thing for the cross slope, and the different colors show the severity of the cross slope. There's bad cross slope in the red sections. The green cross slope has good cross slope. Here, the pink area is showing all the gaps where the horizontal gap between the sidewalk panels is too large. And the orange triangles are all the tripping hazards. And tripping hazards, I want to say, well, how big are those tripping hazards? Well, all the yellow ones are less than a half inch. So that means I can go out there with a grinder and just bevel those. But the red ones and the orange ones on there have to have the panels taken out and redo the work. So we give the city manager, with the collection of this data, which we did for the whole city of Gardnerville and Minden, where we live, we collected all the data in 80 to 100 hours. We collected all the data on the major access routes in this town to be able to collect that. So now I'm going to talk about some universal design standards for products. So if you're designing a product, how can you make it more accessible? Well, we're working on accessibility standards for fitness equipment, so that when fitness equipment manufacturers make their equipment, that it's more accessible. So here we have a situation where we've got a seat system that's on there that's too small. Mike Smith is a paraplegic. He's a wheelchair pilot as well, and he's trying to sit on this equipment and he can't do that. Some people can't step the height to get up onto a treadmill. The treadmill needs to be standard step height to be able to get up onto it, to get onto it. How about the handrail on the treadmill? I can grab this one with my hand around it, but this one I can't even get my hand around it to hold on to that treadmill. So that's not a good universal design. What about the weight pin? How many weight rooms have you gone into where the pin is black and the weight stack's black and you can't figure it? You're having to braille it, even if you can see, to find where's the pin to adjust the weight. So we've come up with a color contrast procedure for that. What about the pin itself? It should be designed so you can grab it without finger function, to be able to hook your fingers around it. How about visual contrast? So here's a display on a well, I won't say whose manufacturer it is. It's a treadmill, okay? So we see the contrast. Here's what it looks like in black and white. You can't see the contrast at all. So here's another piece of equipment, and you can see that in black and white. It has good light to dark contrast. So you have to think about everything you design, the text, the fonts, the symbols, everything has to have good color contrast. So we're also working on the universal design standards for products used by people with cognitive impairments. So if you have some sort of a cognitive impairment because of a head injury, or perhaps a child born with a disability that causes a cognitive impairment, you want to be able to rate basically complex versus simple cameras, cell phones, toasters, microwaves, fire extinguishers. We want products to be intuitive and easy to use. So we're working on developing a set of assessment process to rate products for universal design for cognitive use. I also work as a consultant to the amusement park industry. Some rides you can roll right onto and sit in your wheelchair. That's great universal access. Other rides you have to transfer into. Spider-Man and Transformer, for example, the whole shell of the ride folds up, making it really easy to pull into the side, transfer into the ride, pull the shell down, and off the ride goes. Other rides, we have to come up with a way to make a fold-down barrier so that you can get into the ride and fold that back up so it's safe. You're not going to go flying out of that roller coaster. Jurassic Park, that was a water ride. That's an old ride. How do we make old rides accessible? So we came up with a mock-up of the seating system and looked at how that would be positioned next to the wheelchair to transfer in. And then this is the final design. It plugs onto the side of the ride. First you transfer to this part, then you transfer down, then you transfer into the seat. So I've got to make 3 transfers to get into the ride, but I'd never be able to make the single transfer to get down into that seat. I can make the 3 step-by-step transfers to get into that ride. So I was able to ride that ride with my daughter when we finished the design of that. This is a roller coaster designed in Germany. It has a single restraint over the body and very minimal shell around the seat. This was used to create the Rocket roller coaster. If you've ever ridden that ride down in Florida, it has got a vertical launch. You go straight up slowly, and then it drops you down. Well, it's got all sorts of inverted twists and everything. So here I am in the mock-up trying to figure out, okay, how am I going to transfer? Here's the simulated position of my wheelchair on these 5-gallon buckets with the wood underneath. That's where my wheelchair is going to be. How am I going to get past this thing to get into the seat? So we had to design a transfer chair. So here I am sitting on the transfer chair, and it's counterweighted in the back. So they actually plug me into the ride, and then I can make a simple lateral transfer into the seat of the ride. And there I am sitting in the ride to be able to ride the ride. So in that case, we had to make an intermediate transfer device with wheels to help get the person into the ride. We make a reasonable accommodation. We design a reasonable accommodation for every ride. And we work on all the rides at Universal and Disney on their ride accommodations, all the new stuff. So this is our brand new project. We just started the 1st of January. So I took these slides actually yesterday, I think, and then sent them to Dave. So I'm going down a boarding, all of you have been down the jetway to the plane, right? You get down to the jetway. Well, when I get down to the jetway, typically what you have to do is get into an aisle chair. So here's the aisle chair that I've got to transfer into. There's all these people around me with various levels of training and experience. I've got to transfer from my wheelchair up onto this aisle chair seat. Okay, there I am getting on. Now I'm on the aisle chair seat. Then they got to strap me in. They've got straps that go across both shoulders, across the waist. My feet are falling off the chair. I don't fit in this thing well. It's not comfortable. It's got to be operated by somebody else behind me is pushing me in this little skinny thing to go down the aisle of the plane. So let me show you what I came up with for myself. So I was okay, I'll build some aisle chair wheels. So I make these extra wheels under my chair. I can take my big wheels off. So I get down to the jetway. I grab onto something. I pull off my wheels. One, then the other. Then I pull myself over to the plane. Pull myself over the little bridge going into the door of the aircraft right there. And now I've pulled myself into the space. This is the front row seat. That's the bulkhead there. So this is the front row and coach. Okay, I'm behind the first class section. Got myself pulled into that space, and then I'm holding on to the overhead compartment up above, and I transfer into the seat. So now I'm in the aircraft seat, and there's my wheelchair, and I fold up my chair, and I fasten it shut, and it fits into the closet of the aircraft. The other problem is the aircraft seating itself. So here I am, sitting in the aircraft seat. Okay, looks pretty good. Feet are on the floor, pretty good fit on my back. But wait a minute, that's the aircraft seat cushion. I can't sit on that for 2 hours. I have a spinal cord injury. I need to sit on a pressure relief cushion. Okay, so here I am sitting on my pressure relief cushion. I'm sitting a lot higher. My feet are not even on the ground. My legs are dangling. My back is now, the part that's supposed to be my neck support is now pushing my shoulders forward. And so now that's pushing my head forward. Now I've got to tilt my head back, I have my neck extended, and my elbow's off the armrest. I can't even put my arm on the armrest. So I can't even sit comfortably on the aircraft seating. Okay, so this is the kit that I currently carry with me. I got my backpack that's right here. Backpack becomes the foot support, okay? So now I've got my legs supported properly and my feet supported. I've got my seat cushion. I've got a lumbar support in the back there. I've got support down my spine, and I've got a neck support. Now I can sit comfortably. These are all the things that I had to carry. I've got my backpack. I've got my seat cushion from the wheelchair. I've got my inflatable REI headrest serving as my lumbar support. I've got my down vest rolled up into a tube for my spine support. I've got my neck support pillow, and I've got a towel underneath my arm. So this is need, right? Okay, I see the need, I see the problem. This is where we're starting with the problem. What's the kit that we're going to come up with to create the solution for everybody to be able to have a simple stash of stuff? Obviously, I don't have to sit on my wheelchair cushion. If I could have a lower profile cushion, I could take advantage of the foam that's already in the aircraft seat, plus a special layer on top of that for the aircraft seating. So we're going to start making pressure measurements with lots of low-profile cushions to figure out what'll work. We're looking at, there's a dozen different foot supports that you can find for office workers and things for foot supports. We've already found the back support one that I know works good for me, but what about people that need lateral support? What about people that need something to stabilize them? We might need something to strap around the seat that gives a little bit of lateral support for people that need some support there. Some people have contractures. They might not be able to go all the way back into the seat. So we're partnering with the occupational therapists in Chicago at the Rehab Institute of Chicago, where all the training centers are for the airlines. We're going to bring people through and we're going to come up with a kit full of stuff, and we're going to try fitting these people into aircraft seats. So we've got these aircraft seats that we can use. We'll get them all set up. We'll send them out to Chicago. We'll figure out a protocol. I'll be the first test subjects. We want to get the protocol down to 2 to 3 hours if possible. We're probably going to end up having to do the work at 10 o'clock at night or later, because that's when all the airplanes are in the airport and we can actually do the boarding. So we're going to be doing this like after hours. It's be like, everybody goes away, goes home from the airport, and there's all these empty airplanes sitting there. That's where we're going to try to do our research. So we're going to have subjects, we'll have to come up with popcorn and movies or something to keep them entertained while we're doing this stuff. So this gives you a feel for what's going on. There I am on the ferry boat ride. No restraint there, just holding on with my arm as we're bucking our way through the waves out under the Golden Gate Bridge to be able to, the whole idea is for people to keep their quality of life and keep going out and being able to do things. So Dave, that was a great idea. I made a cue of what slide I needed to be on every 10 minutes. Dave was worried I wouldn't be finished with my slides. So 207 slides, Dave. I did it. All right. So we have 5 minutes left.
Yeah, you practice your slides, so that would be awesome. So if anybody has any questions, now is the time.
And I'll be happy to stay. In 5 minutes, some of you have to go to your next class, and I'll stay another. I think we can stay in the room another 15 minutes, and then I'll stay here after that outside the door, and then you can come with us to dinner if you want. Go ahead.
So you mentioned multiple times that you published papers on a lot of this research. Do you have one journal in particular that you tend to publish in, or is this more like published on your website sort of stuff? Or?
Yeah, there's references on our website. If there's any project you're interested in, you can send us an email and we can send you the articles electronically. Also, there's a journal of rehab R&D. The VA publishes a journal. It's called JRRD. I think if you just Google that. There's also a journal of assistive technology by RESNA, which is the Rehab Engineering and Assistive Technology Society of North America, RESNA. You can Google resna.org, and they have a journal. There's also magazines like Sports and Spokes magazine, stuff. If you go in the archives there, Paraplegia News magazine. There's a magazine called New Mobility that has all kinds of adaptations and stuff. So there's some good publications.
So I want to make it clear that there's a distinction between journalists that are referee and professional.
Right, and the magazines. Yeah.
And then there's the stuff that gets published on the website. So those are the three different publications. As a professional, if you're a professional engineer doing research and stuff, you want to produce a high-quality article that's in a referee journal, because that's what you do.
In fact, we made Irene start the article, and she's first author. Just finished her internship on that developed outdoor recreation assessment process, and she did a repeatability and reproducibility study with different people making the measurements on the same picnic tables and pumps and everything to see if they could repeatedly get the measurements. So she learned how to do a research study. Now she's absolutely sure she just wants to go into clinical work, I think, after the experience. But she got an experience of what it's, because even in a clinical environment, she may need to do clinical research to determine if something is repeatable in the way you can set up a particular seating adaptation for someone in a wheelchair or something. So you can ask her questions afterwards too. She's available as a guinea pig. And Arn has worked with me for 20 years too, so you can ask him questions as well.
How are the thoughts like whether or not the services were safe?
The firm and stable?
Yeah, or like,
What we did is we actually did a research study with human subjects, and we built trails that were 100 meters long. And so the trail was mostly straight, but about 20% turning. And so we had people measure the metabolic equipment. We had them rolling and walking and on those trails back and forth till they're physiologically they stabilize, and we could measure how much work they were having to do to walk on those different surfaces compared to a paved surface. And so we were able to quantify the energy expenditure and the difficulty and the rating of perceived exertion for those different surfaces. And so that's a really great question. We did it at the Bonnie Doon Airport in the Santa Cruz Mountains. The owner let us build those 9 different trails there. You know, we had everything from sand to pea gravel, and you know, some of them the sand you roll 5 feet and you're stuck. You know, and decomposed granite. We used stabilizers in some of the surfaces. We had asphalt. We had concrete. So we used a dozen surfaces. If you go to access-board.gov, which is the Access Board website, and you go to their technical bulletins, the one that begins with the word accessibility has all the results of that research, and it correlates the human subject testing with the measurements with the rotational penetrometer and the ASTM test procedure, so that we know the correlation. And that's how we were able to establish some preliminary guidelines for what we thought should be cutoff values for firmness and stability. So we have values for firmness and stability, like for this building, versus moderately firm and stable for a playground where you're only wheeling a 30-foot distance, where it can be a little bit more like going up a ramp, if that makes sense. So we always compare to standard slopes when we do that testing.
I think one of your messages here is that it's great to come up with a new design. And you say, well, this is a great design. But
Yeah, you have to show
to
it.
people that it's better to do that by measuring, taking these measurements. And sometimes having a device to measure how good your
Is more
product
important.
is really important to do. So.
Yeah, until in the later part of my career, you see I'm doing more things that affect the design of the environment and the assessment of the environment, because it has a much broader, a broader application that's going to help everybody in our country as they get older, and everybody ends up losing their mobility at some point in their life. So that's my focus toward the end of my career, is to make an impact on things that affect the whole country. Yeah.
Moving forward, what I really picked up on your presentation is that the scientists, most often in my travels and trails, you see this wheelchair access.
Right. What does that mean? Yeah.
Everything.
Yeah.
What you've shown us here is the universal language.
Yep.
Because when you see wheelchair access signs, most people that are with you are thinking, well, you got to go there. I'm not going there. You're
Right.
going to be done here.
And the mountain biker's looking for something that's steeper, so he wants to find things that are at least a certain steepness too.
So with your signages, it tells me it equates and equals the playing field.
Right. Lets me figure out where I can go, what adaptive equipment need, what kind of assistance I might need. I can make choices about what kind of trail I want to do based on what equipment and what people I'm with and that kind of thing. Yeah. Any other questions?
5:30, so it's, thank you so much.
All right.
Coming to
One of our clients is here, by the way, in this wheelchair. You want to see the chair we're working on. It's a 4-wheel drive wheelchair in the back called a Will.
Thanks so much. If you want to come down and talk to Peter, we'll be around for a little while. Otherwise, have a great weekend.
Hey, how you doing?
Peter. I'm doing great. My name's Dan.
Hey, Dan?
Yeah, really great presentation.
Yeah.
Thank you.
You're welcome. Hey, hi.
I have a